On April 13, 2029, an asteroid the size of 3.5 football fields, with a staggering mass of 27 million tons, will hurtle just 31,600 kilometers above our head. That's closer than many of our communication satellites. Closer than our own moon. This is 99942 Apophis, and while it won't hit us, this cosmic encounter is set to fundamentally alter our trajectory and our understanding of the universe forever.
Discovered in 2004, Apophis initially presented a chilling probability of impact. 1 in 37. Those were cosmic roulette odds that had scientists worldwide holding their breath. Its density, estimated at 2.6 tons per cubic meter, pointed to a solid, rocky composition that, had it struck, could have unleashed energy equivalent to 1,200 megatons of TNT. Dozens of times more powerful than the largest nuclear bomb ever tested.
The asteroid threat isn't science fiction. Remember Chicxulub, which unleashed 100 million megatons of TNT, altering global climate for years? Or Chelyabinsk in 2013? A mere 20-meter object that injured over 1,600 people. Apophis, at 340 meters in diameter, is dramatically larger. This isn't about fear anymore. It's about scientific certainty. We've mapped its every mile. We know it won't hit. But what will happen is a cosmic ballet we've never witnessed. In April 2029, it will thread our cosmic needle, slicing through the region below the 36,000-kilometer geostationary orbit, even dipping lower than the 2,000-kilometer densely packed low Earth orbit, where thousands of our satellites operate. Hi, I'm Daniel Levon, and on Astrovan, we're diving deep into this incredible story. You've heard about its terrifying potential, but what exactly is this space rock made of? And what incredible secrets does it hold about the origins of our solar system? So, what exactly is this monster that's about to grace our skies? Apophis, officially categorized as an S-type near-Earth asteroid, or NEA, is a rocky, silicate, and metallic amalgamation. Quite similar to many meteorites that land on Earth. Scientists speculate it likely originated in the main asteroid belt between Mars and Jupiter, then got gravitationally flung inwards, becoming a rogue traveler in the inner solar system. With an estimated density of around 2.6 to 2.8 tons per cubic meter, it's no mere snowball. This is a solid cosmic mountain of rock. Initial spectral analysis suggests Apophis is rich in nickel and iron, potentially making it a future mining target. Studying its composition won't just unveil its past, it offers clues about the building blocks of the early solar system. This isn't just a rock, it's a speeding geological time capsule. While we now know Apophis won't strike, it's crucial to grasp why it was so feared. Had its orbit been just slightly different, an ocean impact could have triggered tsunamis up to 300 meters high, obliterating continental coastlines within hours, with waves traveling at 800 kilometers per hour across oceans. A strike on solid ground would have unleashed its 1,200 megatons of TNT of energy, carving out a crater approximately 5 to 10 kilometers wide and up to 500 meters deep, followed by devastating seismic shock waves and supersonic winds exceeding 1,000 kilometers per hour. Dust and debris would be hurled into the atmosphere, potentially blocking sunlight for months, ushering in a mini year without a summer, disrupting global agriculture, and sparking worldwide food crises. Remember, this is a hypothetical scenario, a stark demonstration of extreme natural power and why planetary defense science is so critically vital. The razor-thin margin between if and not is a testament to scientific triumph.
Even before Apophis' orbit was confirmed safe, scientists were already seriously thinking about solutions. Various mitigation methods have been meticulously developed and studied. Take the kinetic impactor concept, for instance, which is no longer just theory. NASA's DART, Double Asteroid Redirection Test mission, successfully impacted asteroid Dimorphos in 2022, altering its orbital period by a definitive 33 minutes. This proved we can deliberately launch a spacecraft to crash into an object, changing its velocity by just a few centimeters per second, enough to shift its impact trajectory over years of travel. Then there's the more subtle gravity tractor method, where a spacecraft flies alongside an asteroid, using its own minor gravitational pull to gently nudge the object off its dangerous course without physical contact. Pioneers like Dr. Brent Barbee from Goddard Space Flight Center are examples of scientists dedicating their careers to developing these strategies. These technologies, now forming the bedrock of our planetary defense programs, are tangible proof that human ingenuity can stand up to cosmic threats. Apophis, in a sense, became an early proving ground for our planetary defense dreams.
After years shrouded in fear, Apophis has now transformed into an unprecedented cosmic spectacle. On Friday, April 13, 2029, this object will reach its closest point to Earth, hurtling just 31,600 kilometers above the surface, roughly 1/10 the distance from Earth to the Moon. Across much of Europe, Africa, and Southwest Asia, Apophis will be visible to the naked eye as a rapidly moving star, comparable in brightness to the brightest stars in the Little Dipper. Its speed, reaching 37 kilometers per second relative to Earth, will have it zipping across the night sky at an observable pace. During its peak, from Eastern Europe to Asia, It will traverse the sky as fast as a geostationary satellite, covering an angular width of a full moon in just about 1 minute. This is a once-in-a-lifetime opportunity for skygazers, both amateur and professional alike. A tangible demonstration of celestial motion typically only seen through telescopes. This event isn't just a visual spectacle, it's also a gigantic natural laboratory. Observatories worldwide will be pointing their most powerful instruments at Apophis. Optical telescopes like Hubble, or array systems such as the Very Large Telescope, VLT in Chile, will map its surface with incredible resolution, searching for new geological features and signs of any tiny moons that might be orbiting it. But the real star of this observation will likely be radar telescopes. By bouncing radio waves off it from Earth, as done by NASA's Goldstone Antenna or the Green Bank Observatory, we'll receive echoes that allow scientists to build incredibly detailed 3D models of its shape, rotation, and even surface topography down to a few meters of resolution. We'll see Apophis like never before. Every single observation will generate terabytes of raw data, a treasure trove for asteroid studies for decades to come. But there's one scientifically fascinating aspect: how Earth's gravity will fundamentally transform Apophis. As the asteroid whizzes past us, Earth's powerful gravitational tug will dramatically alter its orbit. Scientists predict its orbital period around the Sun will shorten from 323 days to approximately 304 days. This change, while seemingly small on a cosmic scale, is profoundly significant and will affect how Apophis behaves in the future. Furthermore, this flyby is also expected to trigger an updated Yarkovsky effect. The Yarkovsky effect is a subtle thrust generated by the asteroid's own thermal radiation as it heats on one side and cools on the other during its rotation. The gravitational interaction with Earth will modify Apophis's spin state and surface, which in turn will change its Yarkovsky effect, either speeding up or slowing down its rotation, or even influencing its orbital path slightly further. Understanding these changes is key to precisely predicting the future paths of asteroids, not just Apophis, but for thousands of other near-Earth objects. The mission to Apophis is not without precedent. Scientists have honed their capabilities through incredible endeavors like OSIRIS-REx. This mission successfully collected samples from asteroid Bennu, a carbon-rich object abundant in ancient organic material. After a 7-year journey spanning 6.2 billion kilometers, OSIRIS-REx returned over 250 grams of Bennu samples to Earth in September 2023, offering us direct insight into the formation of our solar system. Now, that very same spacecraft, rebranded as OSIRIS-APEX or Apophis Explorer, has an equally vital new mission. After releasing its sample capsule, the spacecraft will embark on a journey to Apophis. Utilizing the same advanced instruments like the OTES thermal spectrometer
the OSIRIS visual and infrared spectrometer, and the MapCam imager, OSIRIS-APEX will fly within 5 meters of Apophis' surface after its 2029 Earth flyby, studying the changes induced by Earth's gravity. This is a monumental leap forward in asteroid exploration, building on past successes to understand the celestial objects most relevant to our planet.
The data OSIRIS-APEX collects will have incredible long-term implications, not just for planetary defense, but for our fundamental understanding of the cosmos. By studying how Apophis transforms after its gravitational interaction with Earth, we can refine our orbital prediction models for thousands of other near-Earth asteroids. This is key to safeguarding our planet from future impacts. Beyond that, Apophis' compositional and structural data will provide invaluable insights into solar system formation, even potentially identifying asteroids rich in water or rare metals, opening the door to future space resource mining, which could sustain long-term deep space exploration. Who knows? Perhaps organic materials found on asteroids like Apophis will yield clues to the very origins of life itself. This mission isn't just about a rock. It's about our future in the universe.
The story of Apophis is a saga of science, courage, and global collaboration. The success in predicting its orbit, developing mitigation technologies, and now sending an exploratory mission is the fruit of international cooperation that transcends national borders, ideologies, and cultures. NASA, ESA, JAXA, and observatories worldwide work as one. What's next after Apophis? Planetary defense efforts won't cease. Missions like NEO Surveyor and Infrared Space Telescope are slated for launch to systematically search for and catalog 90% of near-Earth objects 140 meters or larger, the threshold for significant impact threats. We continue to build our defenses, one step at a time. Yet, the Apophis narrative is also a profound philosophical reflection on our vulnerable place in a vast universe. It reminds us that we are inhabitants of a tiny island in a cosmic ocean, susceptible to forces beyond our immediate control. Yet, through collective intellect and the spirit of exploration, we find the strength to understand, to predict, and perhaps one day to even manage our own cosmic destiny. Apophis teaches us that the sky isn't a limit, but an invitation to understand, to protect, and to keep looking up with curiosity and hope.